This is a circle, and this angle indicates a portion of this circle. How do we now quantify exactly this portion, or how do we put a number on it? We know, of course, the most obvious way to do this. When we divide the entire circle in 360 pieces, the portion of the circle corresponding to one piece we indicate as 1 degree. However, this division in 360 is quite arbitrary. Why not divide it in 12 pieces, as we do with clocks, or 60 if we count for minutes, or divide it in 365 pieces, as we do with the orbit of the Earth around the Sun? What exactly is the right choice? Well, this is where radians come in as a way to divide the circle in an unarbitrary way. But how exactly? A circle is fundamentally determined by its radius. Now trace the circle over the length of exactly 1 radius, and the resulting angle we obtain is defined as 1 radian. In this way, we are cutting up our circle in pieces according to the fundamental quantity. But why? What do we exactly gain? We certainly lose something, since it turns out that if we keep tracing lengths of 1 radius around the circle, we don't exactly end up where we started after 1 revolution. In fact, we never land on the same point twice. This raises the question, how many radians do exactly fit in an entire circle? Or in other words, how many times does the radius of a circle fit inside its circumference? And this, of course, we know. It's exactly 2 pi times, which directly follows from the formula of the circumference of a circle. C is equal to 2 pi times the radius of the circle. And this relation also allows us to connect our beloved degrees to radians. Namely, 360 degrees, or 1 full circle, corresponds to 2 pi radians. And likewise, 180 degrees corresponds to pi radians, and so on. As an added bonus, we can now understand the formula to calculate the length of any section around a circle. S, the section around the circle, is equal to the angle in radians multiplied with the circle's radius. And this checks out, since the entire circumference corresponds to an angle of 2 pi radians, and we again retrieve the formula for the circumference. All in all, radians might seem to be a strange way to measure angles, but just remember that it is the least arbitrary way to do so.